So today I want to talk about duck typing and type conversion in Ruby. So you might ask, why talk about duck typing? Well, I was coding for Ruby in Ruby for a year or two when I started asking the question, what is duck typing really? And what does it mean to actually do duck typing correctly in your code? So I don't know if you're anything like me, but if you are, then the first thing that comes to mind when you think duck typing is this guy, unfortunately. And he says, if something walks like a duck and quacks like a duck, then it must be a duck. And that's essentially what duck typing is. I also went onto the internet and I looked for some more formal definitions, and I found a couple. So here we have somebody saying that duck typing is concerned with the suitability of an object for some purpose. It focuses on the messages that an object can receive rather than on its type. And we care about how an object behaves rather than about its insides. So the general message seems to be is we don't care how something works or why it works, we just care that it works. Now, duck typing is actually a type of type system, and a type system is basically just a collection of rules that assigns a type property to things like variables, functions, and expressions, and that information is then used to try and prevent errors in the system. Now, there are several types of type systems, and you can classify them according to various rules, but maybe the most well-known would be your static versus dynamic type system. So your static type system does the type checking at compile time, and the dynamic one obviously does it at runtime. Then you can also have, just for interest's sake, you can have gradual type systems, and that's a mix of static and dynamic. So, for example, a good example is TypeScript. Apparently, you can declare a variable and say it's an int, but you can also declare it as having type dynamic. Okay, then you can have manifest versus inferred type systems. In a manifest type system, you explicitly state the type of a variable, whereas in an inferred type system, the system actually automatically deduces it for you. Then you get nominal and structural type systems, where the type is deduced from the name you give it in the nominal type systems, and in the structural type systems, it's deduced from the structure. And you can get something called soft type systems, where basically an object is required to have a certain predefined partial structure in order to qualify as being of that type. And then finally, you also get duck typing, which only checks the partial structure. And in fact, in duck typing, you only check whether an object actually has a single method when that method is called on the object. So it's very loose. Now, there are some advantages to having your more traditional type checkers, especially the static ones. For example, documentation can be very easily extracted, right? Because you're saying parameter types, you're saying what the parameter types are, you're saying what the return type is, and so automatic extraction of documentation becomes very easy. You don't need to write any tests to check whether your methods actually handle different input types correctly, and so your test suites won't bloat. Errors will be caught really early at compile time rather than at runtime. These systems tend to be a little bit faster as well, because apparently compilers can make some optimizations if they know what the type of a variable is going to be beforehand. And you tend to get more meaningful error messages because, well, you get an error as soon as you try and pass a type of the incorrect type into a method, rather than seeing what happens and having something go wrong down the line. Now, on the other hand, there are also some cons of having a more traditional static type checker. For example, you need a compilation for every change, and that's going to slow down your development. I know when I started using Ruby, I really love this about Ruby. You make a change in the code, you refresh your browser, and there it is. You also get, with a static type checker, you get a loss of expressiveness because you start having to declare the types everywhere, and this is not the way we actually speak in the normal day English language or the way we think. If you're doing mathematics, you say x equals 1. You don't say int x equals 1 because it's kind of implied. And so you lose some expressiveness if you have to specify types everywhere. Then you obviously can't have any duck typing with a static type checker. And finally, your code tends to be a little bit less dry because you're having to repeat types everywhere. When you declare the variable, you say its type is int. Then in the function, in the parameter list, you have to say these are ints. Return types has to be specified. Inside the function, you have to specify types. And so there's a lot of repetitive things going on when you have to keep declaring types. So sure, static type checkers do have some advantages, but All of these things are things that actually really have drawn me to Ruby in the past, and what I found makes it really nice to work with Ruby. And so I think that if we were to introduce a static type checker into Ruby, it certainly wouldn't feel like Ruby anymore. It wouldn't be the Ruby way. So if you are desperate for a more formal type checker in Ruby, it's possible to get one of those, and I'll mention that a little bit later. But what I'd like to talk to you about today is how do we write code in a way that we can sort of try and avoid some of the disadvantages of not having a more traditional type checker in Ruby. Now the point, whoops, sorry about that. Now the point I'm going to try and make here is that it's not really about finding one way that works and sort of trying to apply that sort of consistently over your whole system, saying this is how we're going to check types, and that's just the way it's going to be in the program. The idea is it's about context, right? It's about what is this particular method doing and what's happening in this method and what's going to make the most sense in that context in terms of trying to prevent type errors. So yes, it's not really about using the same approach everywhere. Okay, so now the first way to do duck typing is basically just plain duck typing. So over here I've got an example where I've got a method and I'm passing something into it and I'm trying to make it quack, right? And I call the method on it. If it works, great. If it doesn't, it's not my problem. And this approach is actually fun. There's nothing wrong with it. And I mean, I actually really enjoyed this aspect of Ruby when I started coding in it, because I wasn't bogged down by having to specify types anyway, and it felt really natural and it felt really expressive. But what I also found was that if you're the single programmer on a program and the program is quite small, this works great. But as soon as the program starts getting bigger and you start working with more developers on the program and they start using your code, taking a sort of steamroller approach using this everywhere tends to end up doing something like this to not only the program, but also to your fellow developers. So you basically end up screwing them. And the reason I'm saying is this is that you start getting a lot of errors that look something like this in your system. So you'll see here we have runtime error, undefined method data for 6 fixed num. Okay, so obviously this is a duck typing error, right? We're trying to call a method on an integer here that doesn't exist. And now you try and think, okay, well, what went wrong? So you take a little bit of a look at the information that's given to you, and you read a bit and you realize, this is just a garbled string. I don't actually know what's going on. So, but it's cool. We have a stack trace. So let's look at stack trace. We see, oh, something went wrong in new translated hash. And we look a little bit lower down. And after a couple of minutes, you realize, actually, I don't know what the fuck's going on here. Something went wrong, but I don't have a clue what. And so now what happens is you have to firstly try and reproduce the error. And secondly, the way to debug this will probably be to start inserting a whole bunch of breakpoints, and you spend an hour or two, if you're lucky, trying to debug this problem. And maybe it's an hour or two that you don't have. So my question is, what can we do to try and prevent these errors, or at least try and make them easier to debug? And I'm going to suggest a couple of ways to do this. The first one is we can just use respond to, right? So here's a simple example. We check whether a method actually exists on the object first, and if it does, we call it. Otherwise, we just return null. And I found that this actually works really well in a lot of the cases. Our systems tend to be geared to handle null return values from functions, all right. And so if this is what works in the context, then fine. Now, I did some reading about this, and some people think this isn't actually duck typing, because now we're checking whether the method exists on the object first, and if it does, blah, blah, blah. And I thought about it a little bit, and I kind of get it, and I also kind of don't. And eventually I just thought, frankly, I don't give a fuck. If it works, then it works, right? If this is going to make your code more easily manageable, if it's going to avoid errors in your code, it's going to make the clients happy, and it's going to make you more money, then at the end of the day, this is an absolutely legitimate approach to use. Obviously, if it's going to make your code harder to maintain, etc., then it's not the right approach. But often enough, this works, and that's fine. Okay, so another thing we can do to try and avoid type errors is to actually do some type checking of our own. So here we have make it quack method, where we pass something in, and we check, is it a duck? If it's a duck, we do something. If it's a string, we do something else, etc. Now, I tend to kind of cringe a little bit when I see this in Ruby, because it doesn't feel very Ruby-ish at all to do type checking. But I've seen this a couple of times, and I've actually resorted to using it myself. So if this is what works in the context, then that's fine. I don't know if you noticed something when looking at this case statement. We're going case thing when duck. And it reads really naturally and expressively, and you almost don't realize you're not actually calling is a or kind of or anything like that to do the type checking. It kind of just actually works. And the reason it works is a direct result of duck typing, actually. Because what this case statement is doing is it takes this duck over here, this in the when clause, and it calls triple equals, and it passes the thing to this triple equals method. So it's going to be a bit hard to code while I've got two hands that are busy, but what's actually happening is this, right? And duck over here is a class, so it's an instance of class. Triple equal has been defined on class to check whether its parameter is an instance of the class. And this is the reason that the if statement works the way it does, because of the way that triple equal has been implemented on class. And so you find this is, as a result of this, this case statement reads really naturally, and that's often a result that duck typing has, is to make things feel really natural and really expressive. And it's certainly something we don't want to lose. Okay, so now that we're on type checking, we may as well talk about type conversion in Ruby. Now the idea is with type conversion to basically, if you receive a parameter into your method, and you want to be sure it's of a certain type and try and prevent type errors, you can always try and convert it, right? And so there are three main ways in which you can do this in Ruby. The first is via your conversion protocols. So that's with the two I's and two S's, etc. The second is conversion functions. So these functions have the same name as the type that you're converting to. And then there's a third called type coercion in Ruby, and that's done during arithmetic operations. But I won't have time to go into that today. So I'll take a look at the first two. Now, your conversion protocols are your two I's, two S's, two D's, etc. I'm sure we've all seen them around and used them extensively. There is something to keep in mind, though, when you are busy writing a class of your own, and that is to consider which conversion protocols should I be defining on this class, because thinking about that can end up making your life a lot easier. So to show you an example of that, let's consider this class over here, emacs_config file that I'm creating. You'll see it has a file name that gets set and some properties which I know nothing about. It doesn't really matter. And suppose now that we decided, I want to just read the contents of the file on disk. So we create an emacs_config object, and then we need to call file.open. And so what happens now is we need to expose the file name somehow and pass that file name to file.open, and then we can read the contents. Now this is fine, but there is actually a better and more seamless way to do this. And that involves defining the toPath method on this class, right? So we have that return the file name. So now what happens is we still go ahead and we create the emacs_config object, but suddenly we can pass this directly to the file.open method. And magically, file.open knows what to do, and it opens the file and gives it to you to count the lines or whatever. And the reason this works is because we remembered to define toPath on this file. And file.open actually calls toPath on whatever you pass it before it tries doing anything else. And that's what makes this work. So now, this actually blew my mind when I first saw it, because you'll notice this class doesn't inherit from anything. And it doesn't include any modules. It's just plain out-of-the-box class. And defining a simple method on it suddenly just made everything work. And sure, if we look at the previous slide, this is not so much worse, But there comes a little level of disconnect here because you're having to sort of separate the file name almost from this object and pass that to file.open. Whereas here, it feels just really natural. Look, saying like, I've got a file, I'm passing it to file.open, and it looks really neat, and it feels really natural. Okay, so there's also something else to consider with these conversion protocols, and that is if you have a class of your own, it might be worth defining your own conversion protocol like I did here. So obviously on the class, it's just going to return the object because it's a to-Emacs config file. It's a Emacs config file already. But what this does is if you have another method, like I have here with merge with, and you remember, and you take a parameter, and you remember to actually call this conversion protocol on the parameter that was passed in. What this does is it really maximizes the flexibility for the users of this code, because now they can pass absolutely anything into this method as long as they remember to define the to-Emacs config file method on their object. And so the code becomes a lot more flexible to the user, and you're also preventing type errors because you're trying to do a type conversion over here. Okay, so those are the conversion protocols. Now, I don't know whether any of you noticed anything when you were looking at this list. So you'll notice there's a to_i here, but there's also a to_int. So what is that about? Now, it turns out in Ruby, you get two types of conversion protocols. The first is the implicit conversion protocols, and the second is explicit. Now, an explicit conversion protocol is your two I's and your two S's, so they have the slightly shorter names. And the idea is that if you have a class of your own, to define that 2i or 2s or whatever on your class, if your class is not very closely related to your target class, right? So if you think about an active record instance, for example, it's nothing like a string. But you know you can call 2s on it, and you usually get a fairly decent representation of that record. But the idea is basically to get a representation rather than saying, oh, this active record object is actually a string. And the thing about these explicit conversion protocols is that you call them on the object yourself before passing them to other methods, especially in the Ruby core modules, because the Ruby core modules aren't going to call them for you to do the conversion. So they rely on you to do that yourself. And I'll show you what I mean with that in a second. On the other hand, implicit conversion, they have the slightly longer name, so it's your two ents, two strs, etc. And you define that on your class when your class is very closely related to the target class. So if you have a string class, for example, that maybe has a special representation for null or something like that, then that's when it makes sense to define toStr on that class. And the nice thing about these conversion protocols is that they're automatically called for you by methods in the Ruby core classes when you pass them as parameters. So if we go back to this example with toPath I had, we see this toPath here is actually an implicit conversion protocol that we've defined on our class. And this file.open here is a Ruby core method, and it knows to try and call implicit conversion protocol toPath on whatever you pass it before it tries to do anything else. And so that explains why this works. I can give you another quick example as well of maybe the plus function on the string class. So if we try and do something like this, right? So we go, oh, the time is, and then we do plus time.now. You'll see you actually get a type error, and it says there's no implicit conversion of time into string. And so now we know what this means. It means that there is no implicit conversion protocol on time to convert it to a string, because time objects aren't strings, and they're not closely related to strings. And so what we know we need to do now is we need to call an explicit conversion protocol on this time object ourselves, because Ruby won't do it for us. And when we do that, we see it actually works. Yeah, I think I'm going to leave it at that. So those are your conversion protocols. Now, another way that you can do type conversion in Ruby is to use the Ruby conversion functions. And like I said, they have the same name as the class that you're converting to. And somewhat against the Ruby convention, their names actually start with capital letters, so that's interesting. And the idea is to use these conversion functions to force an object into that type if there's any reasonable way to do so. And so basically, the idea is for them to take a much wider input range than the conversion protocols, and they'll basically try and do anything they can to give you what you want. So if we take a look at what integer does, for example, is it's very flexible. You can start by just passing it an int, and it's idempotent, so it's going to return the same thing. Floats get truncated. You can pass it a whole array of strings with hexadecimal and binary numbers. Integer knows what to do with that. An integer tends to fall back on 2i as well, so because time has a 2i method defined on it, integer knows what to do with that as well. So it's really wide, and it's got a really nice flexibility to it. Now there is a little bit of a surprise with this integer function, and that is what happens when we pass a random string that isn't necessarily an int to integer. You'll see if you try and call 2i on it, you actually get an int back and it's 0. But if you pass it to integer, you get an error. Integer says, I don't know what to do with this. And this actually seems to go a little bit against what we were saying earlier, which was that integer is supposed to take a much wider input range than the conversion protocols. But on the other hand, we also said we try and force the object into that type if there's any reasonable way to do that. And obviously, I think you'll agree that there's no reasonable way to turn a hand sandwich into an integer. If we try, we'll probably end up with something garbled like this. It doesn't make any sense. And so that kind of explains why integer behaves the way it does. So again, you know, Ruby's got certain rules and things that it tries to follow, but if there's something that in the context makes more sense, then Ruby tends to try and take that path because, and that keeps it really nice and natural and expressive. Okay, I might as well mention, I mean, I've never done this, but if you have a class of your own, it might be worth defining a conversion protocol, a conversion function for your class. And what that does, it gives the user the ability to do conversions using this conversion function you've given them. So that might prevent some type errors. And I suppose the advantage of this conversion function is that you don't have to monkey patch your class with conversion protocols. You can just use the conversion function. Okay, now the last thing I'm going to try and suggest that we can do to try and prevent these duck typing associated errors is to actually just throw an argument error of our own. So here's an example where I did this, try and do a couple of things, nothing works, and then we raise an argument error. Now, you might be asking, why raise an argument error? Why not just let the type error happen? I mean, they're both exceptions, right? But I think the idea is to try and put as much information in this exception as possible about what went wrong and what the user can do to fix this. And so what we'll then have is, instead of having this runtime error up here, that doesn't give us much information about what went wrong, we can have a nice descriptive explanation of the problem. Maybe you can tell the user that, look, I know this often happens because 3 levels up, users try and pass an array instead of a string to a certain function, and you can tell them how to fix it. Unfortunately, I wasn't able to actually give you a description here because I still don't know why we're getting this error in our system. So, but yes, and you know, I'm surprised at how well this actually works. You know, and the couple of times we've done this in our system, it has been so helpful, and it's really shortened the debugging time. And on the other hand, I'm also surprised how often we tend to not do this. And I think as Ruby programmers, this is a place we can really up our game just by throwing just a couple of more exceptions. Okay, and I think you'll find that actually the best way to try and handle type errors in your system is to try and use a combination of all of these approaches depending on the context. And what that's going to do is it's going to ensure maximum flexibility for the user while you're still doing your best to keep control over the inputs you accept. So, for example, if we take a look at this myOpen method over here, you see what we're trying to do is we're trying to get a file name out, and we check, does toPath exist? If it does, we use it. Then we check, does toStr exist maybe on this object? And if it does, we can use that. You see, there's a very conscious decision of this developer to not call 2s, because we know 2s is going to give you a string representation of just about any object, and that's not likely to be a file name, right? And so they're exercising caution, and if nothing works, we raise an argument error, telling the user what went wrong and maybe how to fix it. And so this method becomes really flexible because the user is able to pass a lot of different object types into it and get a result, but you still keeping control of the type of errors that can happen. Okay, so that's all I'm really going to say about these different ways you can try and prevent duck typing errors. If you're really desperate, like I said, there are some type checkers available for Ruby. There's the Ruby type checker, and in Ruby 3, we might actually get a type system or a type checking system. So if we take a look at the Ruby type checker, which has been renamed to RDL recently, it's just a gem, and you include it in your project, as you would with any other gem. And what you then do is you just specify the type checking that needs to happen on the methods where you would like the type checking to happen. And so this is really useful if you have a system where maybe there's only a part of the system where the type errors are really likely to happen, or if you allow the type errors to go unchecked, this might be catastrophic for your system. And so what you can do is only include the type checking in that part of your system, rather than trying to force this approach on your entire Ruby program. So I like this because it is so flexible, and it keeps things natural again. And then I'm not going to say too much about this, but apparently there is a plan to introduce a type checking system in Ruby 3, which Matt has dubbed Duck Inference. If we just bring up all the different types of type checkers I mentioned earlier, Duck Inference is apparently going to be dynamic, inferred, structural, and soft. And so the basic idea will be that it will be unintrusive, and apparently it will provide a sort of database in the background of partial types in your system, which will then be able to talk to your IDE and warn you of type errors you're making while you code, rather than having them happen at runtime. And so again, it's really nice that we won't have to change the way we code in Ruby, but this will just be an extra tool to help you try and prevent type errors. Okay, and that's all really I've got to say today. I'm CodeKitten on Twitter. That's my email address. I work for a really nice company called Zappy Store. We do market research software. And if you want to do some more reading about what I've spoken to today, a lot of the stuff I got from this book here called Confident Ruby. And that's it.